Hello everyone, welcome to the AI section of the course. In this section, we are going to cover various AI topics to teach you everything you need to know to create your own custom combat AI using behavior trees. In this video, I will introduce you to the behavior tree system and describe the important aspects that you must know before you can create an AI. Unreal Engine allows you to use the body, soul, brain pattern for AI. The body is the visual representation. An example of the body would be the pawn. The soul is the entity that controls the pawn, which would be the controller. The brain is what defines the AI behavior. The brain is the behavior tree. The memory is where the AI stores information it needs to behave. An example of memory would be the blackboard. A pawn is the physical representation of the player or AI in the game. A pawn can be possessed by a controller. The controller possesses the pawn and can set rules for its behavior. A controller can either be a player controller, which takes input from a human player, or an AI controller, with automated control by the computer. In our analogy, a pawn is the body and a controller is the soul. Behavior trees is a model for switching between a finite set of tasks. It is a hierarchical set of nodes that can control the flow of decision making. The behavior tree can be used when you want AI characters to do their own thinking and make their own decisions. In our analogy, the behavior tree is the brain. There are many benefits to using behavior trees. Some of those benefits include complex behavior. Behavior trees allow for complex AI decision-making behavior. Clarity. Using services and parallel nodes creates trees that are easier to understand. Ease of debugging. Behavior trees are easier to debug than using only blueprint nodes. Event-driven. Unreal Engine's behavior trees are more event-driven, which is easier to optimize. Behavior trees are widely used across the games industry, which is why I have chosen to set up the AI system for this course using behavior trees. The behavior trees have a few different nodes that you can use. There are some important nodes that we need to cover. Composites. Composites define the root of a branch and the base rules for how that branch is executed. Decorators. Decorators are also known as conditionals in other behavior tree systems. Decorators define whether or not a branch in the tree, or even a single node, can be executed. Services. Services will execute at their defined frequency as long as a branch is being executed. Tasks are nodes that do things, such as move to node. Tasks have decorators or services attached to them. Behavior trees execute their logic from left to right and from top to bottom. The numerical order of operation can be viewed in the upper right corner of nodes placed in the graph. In the example image, a sample of a branch placed in the leftmost portion of a behavior tree graph has some nodes that instructs an AI to chase a player if the blackboard has line of sight is set. Composite nodes define the root of a branch, and the base rules for how that branch is executed. They can have decorators applied to them to modify entry into their branch, or even cancel out mid-execution. Also, they can have services attached to them that will only be active if the children of the composite are being executed. There are a few different types of composite nodes which can control the execution in different ways. There is the selector node, the sequence node, and the parallel node. It is extremely important that you understand these nodes and the differences between them. So I'm going to explain each composite node and demonstrate how they work in the engine so that you can understand these concepts. Sequence. Sequence nodes execute their children from left to right. They stop executing when one of their children fails. If a child fails, then the sequence fails. If all the sequence's children succeed, then the sequence succeeds. Sequences are very useful when you want to execute a list of tasks in order, and you want the entire branch to cancel if one of the tasks fail. Selector. Selector nodes execute their children from left to right. They stop executing when one of their children succeeds. If a selector's child succeeds, the selector succeeds. If all the selector's children fail, the selector fails. The selector is more useful when you have a set of paths the tree can take, and you only want it to take one path based on, for example, some parameters. Simple parallel. The simple parallel node allows a single main task node to be executed alongside of a full tree. When the main task finishes, the setting in finish mode dictates if the mode should finish immediately, aborting the secondary tree, or if it should delay for the secondary tree to finish. Okay, now that I have explained the basics on how behavior trees work, let's go into the engine so that I can demonstrate how these things work so you can better understand these topics. I am going to start out by showing you the sequence composite node. So as you can see here, you can visually see the flow of execution, and you can see that a sequence executes every child in order until one of them fails. And you can also see that it is executing from left to right. And you can see the order of execution here, so 0, 1, 2, and 3. And that is the exact order that it is executing in, as you can see from the flow of execution. Okay, and this is a selector. And as you can see from the flow of execution, a selector finds and executes the first child that does not fail. So the wait task is not failing. So the selector will just continually run wait because it is not failing. It finds and executes the first child that does not fail. So that's exactly what's going on here. And it is very important that you understand the difference between a selector and a sequence. Now I'm going to add something that will force this to fail. So I'm going to add a decorator, which I talked about decorators a little bit earlier, but a decorator is sort of like a conditional in other behavior tree systems. A decorator defines whether or not a branch in the tree or even a single node can be executed. So we can use this to force this node to fail. I'm just going to add a time limit. The time limit is going to be 0.1, so that will force it to fail. This one already has a time limit fail after 0.1 seconds, so what should happen is the flow of execution should go here, it will fail, so then it will move on to this one, which will also fail, and then it will eventually go to this one, which will not fail. So let me show that to you. So as you can see, it's working exactly as I said it should. Tasks are nodes that do things. So the wait node is a task. As you can see, it's under tasks, wait. So we're using a task here, and we are using a decorator or conditional to make the task fail. The composite nodes are the selector, the sequence, and the parallel. You can also add a decorator to a composite node. So you can use a decorator on a single task node, or you can use a decorator on a composite node, so that you can define whether or not the composite node will run or abort. Services will execute at their defined frequency as long as their branch is being executed. So let's say, for example, you add a service to this. As long as this sequence is being executed, this service will also be executed. Something else that I'm going to be talking about in more detail later is the blackboard. This is an example of a blackboard. So while the behavior tree executes logic, a separate asset called a blackboard is used to store information that the behavior tree needs to know in order to make informed decisions. So you can add a bunch of variables to your blackboard and use those to control the behavior of your AI. These variables are known as blackboard keys. That brings us to the end of this video. Thanks for watching. I hope this video was able to give you an introduction to Unreal Engine's artificial intelligence system. If you did not understand some of the topics I covered in this video right away, don't feel stressed out about it because this is kind of a lot to take in all at once. Just keep all of this stuff in mind as we go through the course, and as you get more hands-on experience, the things that I talked about in this video will become more clear to you. We will cover some of the other AI topics, as well as the topics discussed in this video in more detail in future lessons, so I hope you look forward to it.